Okay, part C, final one, works the exact same way. Particle moves along the x-axis. We've got our velocity function. We've got our point on the position curve, and we want another point on the position curve at the time when v is 20. So our y1 of x is going to be our x of t with an x substituted in, our position curve, and our y2 of x will be our velocity function with an x plugged in, which is e to the 5x minus 10x minus sine of x. In order to find the position curve, we need the antiderivative of this. So the antiderivative of that is e to the 5x over 5. Remember, you're doing the chain rule in reverse. Move through the constant. Do the power rule in reverse, add 1 and divide by the new power, and the antiderivative of negative sign is positive cosine plus a constant. So here is our position function. To find the c, we know that we are at the origin, so position is 0 when time is 0. So I can plug in 0, I get a 1/5 minus a 0 plus a 1 plus a c. So c is going to be a negative 1/5 or negative 6/5. I can come up and write my position function will be e to the 5x over 5 minus 5x squared plus the cosine of x minus 6/5. So now I'm going to take a break, pause for a second while I put the position and velocity. Okay, so I've put those in, and rather than waiting while we solve on screen, I went ahead and plugged in the solve command for when my velocity function equals 20 to solve for x. I waited and waited for that to pop up, and I had only one positive x output. And we're looking at values of time that are positive, so we're going to ignore the ones that are negative. So the positive one is this 0.66080. So I want the position at that time. So my position was stored in y1, so I'll do y1 of that time, hit enter, and I get a position of 2.851. And we're done.